this question we have to find the value of this given expression. Before solving the question, let's try and understand with the help of few examples on how to represent such numbers in the form of exponents. This will help us to solve this question easily. Now, if we have the decimal 1.1, we can write this as 1 plus 0.1, which can be also written as 1 plus 10 to the power minus 1. Now, if I increase the number of decimal places, let's take an example as 1.001. Now, this can be written as 1 plus 0.001, which can further be written as 1 plus 10 to the power minus 3. Now, if you may have noticed, the power on 10, that is equivalent to the number of digits after the decimal places. So, we can say that the power on the exponent will be equal to the number of digits after the decimal. Again, suppose we have the decimal 1.002. We can write this as 1 plus 0.002, which can be written as 1 plus 2 times 10 to the power minus 3. Now, let's understand the concept when we subtract a number. Suppose we have the decimal 0.9. This can be written as 1 minus 0.1, which can be written as 1 minus 10 to the power minus 1. Similarly, 0.99 can be written as 1 minus 0.01, which is equal to 1 minus 10 to the power minus 2. Again, following the similar concept, we can see that the power of 10 is equal to the number of units after the decimal place. Also, suppose we have a decimal such as 0.991. Now, this can be written as 1 minus 0.009, which can be written as 1 minus 9 times 10 to the power minus 3. So, if these concepts are clear of expressing the decimal as exponents, we now proceed to solve the sum. So, there are 8 nines here. So, 0.99999999 divided by 1.0001 minus 0.99999991 divided by 1.0003. Now, using this concept, we can write the numerator of the first term as 1 minus 10 to the power minus 8, since there are 9 digits after the decimal point. Hence, the power of 10 will be minus 8. And 1.0001 can be written as 1 plus 10 to the power minus 4, since there are 4 units after the decimal point. Similarly, in the second term, we can write the numerator as 1 minus 9 times 10 to the power minus 8, and the denominator can be written as 1 plus 3 times 10 to the power minus 4. Now, one of the basic formulas that is always used in GMAT is a squared minus b squared, which is equal to a plus b multiplied by a minus b. Now, we can understand that we have to apply this formula because the numerator is 2 times the denominator. That means we can write the numerator as 1 minus 10 to the power minus 4 multiplied by 1 plus 10 to the power minus 4. And in the denominator, we have 1 plus 10 to the power minus 4. Similarly, for the second term, we have 1 minus 3 into 10 to the power minus 4 multiplied by 1 plus 3 into 10 to the power minus 4. And in the denominator, we have 1 plus 3 times 10 to the power minus 4. Now, cancelling these two terms, and in the second term, we cancel 1 plus 3 into 10 to the power minus 4. We have 1 minus 10 to the power minus 4 minus 1 minus 3 times 10 to the power minus 4. This gives us 1 minus 10 to the power minus 4 minus 1 plus 3 times 10 to the power minus 4. Now 1 gets cancelled and we are left with or 3 times 10 to the power minus 4 minus 10 to the power minus 4. For those of you who have difficulty in understanding this, in solving, let's take the value of 10 to the power minus 4 as x. Then 3 times 10 to the power minus 4 can be written as 3x. So the expression reduces to 3x minus x, which is equal to 2x. And after substituting the value of x, we get 2 times 10 to the power minus 4. So the answer is 2 times 10 to the power minus 4. Hence the correct answer is option D.